Hello everyone. In this presentation, we'll be learning about naming and classification of enzyme and how does enzyme work. Naming of enzymes. Many enzymes have common names such as trypsin, pepsin, etc. Many enzymes are named based on their substrate like ATPase, which is breaking down ATP, ATP synthase, which is synthesizing ATP. Because of the confusion that arose from the common name, an international commission on enzyme was established to create a systematic basis for enzyme nomenclature. Now, all enzymes are classified into majorly six classes, and these six classes are oxidoreductase, transferase, hydrolases, lyases, isomerases, and ligases. Now, the group of enzymes which are catalyzing oxidation and reduction reactions are coming under the class oxidoreductase, especially your dehydrogenase, oxidase, oxygenase, reductase. These all group of enzymes can come under oxidoreductase. Transferase, these are the group of enzymes which are catalyzing transfer of group from one molecule to other, like transcarboxylase, transmethylase, transaminase. These comes under transferase. Okay. Hydrolases, in this the enzymes which are catalyzing hydrolysis come under hydrolases, especially your esterase, phosphatase, peptidase. Now these comes under hydrolases. Lyases, now these are the enzymes which are also causing breaking of bond, but leading to the formation of double bond, or they are adding groups to the double bond, especially your decarboxylases and synthases come under lyases. Isomerases, these are the enzymes which are causing intramolecular rearrangement, yielding isomers. Okay, like malate, it is being converted to fumarate. It is only isomerization taking place. No, within the same molecule, the transfer of group is taking place. So, your malate isomerase or your epimerase, these all comes under isomerases. Ligases, now under this class, you get the enzymes which are joining two molecules, leading to the formation of carbon-carbon bond, carbon-sulfur bond, carbon-oxygen bond, carbon-nitrogen bond. Especially your synthetases and carboxylases come under ligases. Okay, and since they are joining two molecules, your energy is required. So usually ATP hydrolysis takes place in under the enzymes which are coming under ligases. The group of enzymes which are coming under ligases, those like the pyruvate carboxylase, these enzymes require ATP when they are catalyzing the reaction. The slide is also showing your six classes of enzyme and the type of reaction. Like in oxidoreductase, that you have the enzymes which are which are doing oxidation and reduction. In transferase, you have a group of enzymes which are transferring the group from one molecule to other. In hydrolases, you have enzymes which are causing hydrolysis. In lyases, you have group of enzymes which are removing the one group to form double bond. In isomerases, you have enzymes which are causing isomerization. In ligases, you have enzymes which are joining two molecule together. This table is also showing you 7 classes of enzyme. Here one more class, translocase, has been added. Translocase is a 7th class of enzymes which has been recently added. Under this class you comes and across the membrane bound proteins which are acting as enzyme, like ubiquinone, reductase, ATP synthase. Now these catalyzes movement of ions and molecule across the membrane or their separation within the membrane. Enzyme Commission has developed rules for naming of enzyme, and each class enzyme is classified and named according to the type of reaction it is catalyzing. So it is a class. The enzymes are classified based on the type of reaction it is catalyzing. Either if it is catalyzing oxidation, or it is catalyzing hydrolysis or transfer of group or ligation. Based on those, the enzymes have been classified. Okay. Now each enzyme has been given a unique number which is called which is called as EC number. Okay. Now, like hexokinase, this is the number for hexokinase, that is 2.7.1.2. Okay. Now, the enzyme commission has given each enzyme a unique number, and this number has 4 parts. The first part, that is 2, indicates here is a class. Okay, the first number is indicating the class, the second number is indicating the subclass, the third number is indicating the subclass, and the fourth number is indicating the order of the class. Now, here the hexokinase, the 2 is indicating in which class does the hexokinase belong to. This slide is just showing different enzyme like alcoholic dehydrogenate with its specific EC number, that is 1.1.1.1. Now with the EC number you can guess the it is coming under which class. Like 1, the first number is indicating the class. So alcoholic dehydrogenase comes under oxidoreductase group. Okay. Now phosphofructokinase, the EC number is 2.7.1.11. Now this is coming under second class. Now second class was your transferase group. So phosphofructokinase is coming under your transferases class. Now glutamine synthetase, EC number is 6.3.1.2. Now this is coming under your sixth class, that is ligases. So your glutamine synthetase is coming under your class ligases. Acetylcholine esterase, whose EC number is 3.1.1.7. Now this is coming under your hydrolases. The 3 was your third class, was your hydrolases. So acetylcholine esterase is coming under class hydrolases. This slide is just showing a general mechanism. How does your enzyme work? This is your enzyme and it has a specific active site to which your substrate binds, leading to the formation of enzyme substrate complex. And now this enzyme substrate complex is broken down to your product and back to enzymes. Okay, this is a very generalized mechanism which is showing how does your enzyme works. This graph is showing how does your enzyme work. Okay, how does the enzyme is decreasing the activation energy. Okay, when your reactants are binding to the enzyme, the transition state is formed, and this transition state can be easily broken down to product. The enzymes are nothing but biocatalysts. So what does catalyst does? Catalyst does it increases the rate of reaction. Now, how is it increasing the rate of reaction? By decreasing the activation energy. The enzyme is decreasing the activation energy. What is activation energy? It is the energy to which your reactants has to be raised so that it can be converted to product. Okay. Now, since enzyme is binding to reactant easily, bringing then the reactive group together. So, in this way, it is facilitating the formation of transition state. Now, the peak point is where your transition state is formed. Okay. Now, the enzyme facilitates the formation of transition state by decreasing the activation energy, thereby leading to increase the rate of reaction. Okay. Let's summarize whatever we have learned from this presentation. Now the alcoholic dehydrogenase whose EC number is given. So with EC number you can find which is coming under which class. So its EC number is 1.1.1. So it is coming under which classes of enzymes? Oxidoreductase. The one for the first class was your oxidoreductase. Glutamine synthetase is coming under which classes of enzyme whose EC number is given as 6.3.1.2. So it is coming under sixth class. Now sixth class was nothing but your ligases. So glutamine synthetase is coming under the class ligases. Enzyme increases the rate of reaction by decreasing activation energy. Enzyme facilitates the formation of transition state. Phosphofructokinase whose EC number is given. Now with this is the EC number. So it is coming under which class? It is 2.7.1.11. So it is coming under second class. The second class was your transferase groups. Okay, transferases. So a phosphofructokinase is coming under the class transferases.